graph draws. See if I can make the screen bigger. Maybe it's not going to let me since I'm supposed to be. There it is up there. Okay, got it recording. This picture starts out at 1/2 to the x. The only thing that changed is it went up because because k is 7. We drag and drop. There we go. Okay. For domain of all exponential functions, unless the story has a boundary, go just like the number 9, negative infinity to positive infinity. Notice they have the less than's in there for you. Later on, you'll have to type in the less than's. Because the a number in front is 1, it's a positive number. That's why they have a greater than value for the range. And nothing is, oh, sorry, liar, liar, pants on fire. 7 is being added on the outside. Therefore, that's where the asymptote starts. And so if I was going to draw this, the dotted line would be at 7 and the curve would be coming down like it's landing like an airplane. Thoughts? Observations? Understand? And that's what we talked about yesterday. We're just putting it to use today. We did more than that yesterday, but that's what we talked about. Okay, we're going left, H. This is H. There is, this is the one I was trying to get number 1 to be. Because there's a plus 0 here that you don't see, that's why the range is above 0. Because this guy will never be 0. 1/8 to any power. The higher the power, the smaller the number. Even if your calculator shows a 0, it's not, because it just gets above the calculator's pay grade to answer. But the number line is the domain. All real numbers, we got this same. For me, these decay and growth problems, the hardest thing for me is H. You know, H, it just doesn't seem, as long as you remember H hangs out with X, you're okay. You know, making that little picture in your mind. You won't have any problems, but it's a pickle. Okay, the right comes from H, right or left, so that's why I'm going to drag 7 over there, as it comes from H, just like all of the other graphs, and then up, as they note here, by 2. A number line, negative infinity to positive infinity for the domain. There's not a number that's not, there is no boundary on X. X can be all real numbers from, you know, left to right on the number line. But because of this negative, that speaks to a reflection. So instead of zooming down for a landing, it's coming up, let's see, to the asymptote like this. Okay, that's very poor sketch, but you know what I mean? Coming up like that. That's why it's less than, because A less than 0, Y is less than K. Just destroyed my original, but that's okay. I can remake it. Hopefully better than ever. So I look here, notice the K, that's where it goes. Now we're all caught up from yesterday on to today. Make it a little nicer screen to look at. Okay, 0 because there's a K is 0. Yep. No number means a 0 number if it's being added. Good. All right, vertical stretch. The A is the vertical stretch factor. A is what it is. left is the H factor up high here. So we go left 2. We got crazy X going on there. That's really a negative 2 in that story. And then down by 4. We pick the 4 because units are always positive. You know, units are positive. Number line domain. Don't accidentally, be careful. And you guys know that. We're 8 months into the story. You guys know you have to check your work before you turn it in. And then since 9 is positive, it's a greater than sign, but it's greater than the value -4. So you put in the value of K for the range. That's the dotted line. So if I drew that one, at a -4. Didn't flip, but it does vertically stretch it. So let's go, it's like a really, like a seagull, right? Fast dive, a sharp dive. But it never crosses that. Never, ever, ever. Because no matter what you put into this value, it's going to be added to a -4. So when you add something to a -4, it's never going to be a -4. Because I can never make this term equal 0. Oh, I love the numbers. Now we get to use our reference points we talked about yesterday. Yesterday on the notes there were 2, but I'm only going to use 1 because that's all I have to use. Lazy Fisher here. The reference point you want to use that's handy dandy. You plug in H and you get A plus K out. So that's what's going to help us get this graph. We might not need it if they have different asymptotes or something's different, but if we do need it, there it is. Remember, our original goes through 0, 1. Bless you. And just approach with 0. Yep. So let's see what they want. Okay, notice here. See the asymptote of 2 and the negative out front. That means it's not zooming down, it's coming up towards the asymptote. So A might be it. B did not get reflected. Please let me know. I can't see that. Like, what are you talking about? Let me know. Okay, C is not reflected. B had the wrong asymptote as well. D has the wrong asymptote as well. Where am I getting this? This K number right here. The 2 is K. So that's all I needed was the right side of the asymptote and what the right asymptote is. Correct, because it's being reflected. Remember where you start and what happened thanks to the story. Okay. Asymptote of 2 went left 4. Asymptote of 2, 8's out of the picture. Okay, so it's B or it's C. D has got A and D have the wrong asymptotes. With me? Oh, did I? Guys, I did not. I neglected the rest of number 5. Please let me correct that. Here's where the fun typing comes in. Negative infinity, don't use these. They have equal signs. We do not want equal signs for infinity. You have to use shift, comma, the right variable, shift, comma, and then you go back to your touchpad. Phew, that was close. Range, the variable is y. And where do I get my story up here? Look, it was a negative a, so I make a less than sign, shift, comma. What value do I use? My k value, my number 2 here. So that is k. And just, did I have that? Oh, I didn't have it written up there. Let me write it up there. It's okay if you don't have spaces. It won't ding you for that. So, lazy me. Okay, this is the asymptote. The range, oh, I did say about that. Okay. Range, we do the set of all y such that y is, it will be greater than k or less than k when you go to put it in, depending on what a is. If a is greater than 0, then y is greater than k. If a is less than 0, and they match. That's a nice thing. You know what I mean? Like, that's nice to remember that. That you just type in the y is less than k. That's where I got it from. Because a made the curve reflect. Up here. See how the a made the curve reflect? Should come zooming down like airplane landing, but it comes up. I don't know how to describe that. What kind of real life object makes that motion? You know, and just skims something. Just think about it. Make some picture in your head. If you can have a picture, you can better understand what we're talking about. You will remember it. Okay, back to 6. We got to find a reference point because I have 2 answers that fit the bill as far as above the right asymptote. So I have to pull out my h, which is a negative 4. Let me type it out here. I'll type it out on the screen. Okay, right here. Whoop. Don't go away. There we go. Gotta set it up here. Okay. My h is a negative 4. So if I put a negative 4 in here, my a is 1 plus 2. So my ordered pair emerges as negative 4, comma 3. So if I look at my 2 choices, it's either B or C, because A and D have the wrong asymptotes. Okay, right here. Negative 4, 3 is not on the blue graph. Negative 4, 3 is about as imperfectly perfect as it's going to get in our need to write, you know, use our pencil width, right? So I know what the graph is. Oh, that's hard to see. Scoot it up here, better to see. See where I got my data? Any questions about A plus K? See why A is 1? If I put a negative 4 in here, that becomes the factor of 1, and 1 times 1 is 1. 1 plus 2 is 3. Now we tell the story. Use our negative infinity. I'm always afraid I'm going to type the wrong one first. X, I'm just skittish. Positive infinity. So check. And this is above the asymptote. So my y's are greater than, shift period, my asymptote, which is 2, I can see here. I could see it in my right graph here. See that? I could go back up to my equation, but since I haven't zoomed in. Now you know how to use a reference point to help you find the graph. We're ready to roll. Number 7. Okay, I have an asymptote of 2. It does not reflect. So A is an option. C is an option. I have to dig into the reference point. This is what you're going to have to be doing on the test, friends. This is the test. This is the test. I have 1/5. Don't we love fractions? So if I put 1/5 in the story, that means I get out a half plus 2. So I can change it to a decimal, or I can make it a 5/2, whatever I want to do, whatever. Since 1, 5/2, 2.5, whatever you want to say. I could make that to pickles. I could make it into 0.2 and 2.5, whatever your little brain's happy with. It's fun to play in the fraction playground because life has fractions. I'm trying to make this wider so it becomes just a nice little ordered pair. There we go. Okay. So I go over a fifth. That's like a fifth of the way up. Looks pretty imperfectly close for A. Let me see. If I go over a fifth, does that look halfway for my letter C? You guys think that's halfway up when I move over a fifth? Which one do you think it is, A or C? It's okay to be wrong, but you'll probably be right. Which one do you think goes over a fifth, up 2.5? You're the experts. You and the test. This is how nitty-gritty the test is going to be. What do you think? You got it. Good job. Now, those of you who were hesitant, let me show you. Okay, Rob's here. A fifth is like right here. You see how even crossing here doesn't even look like 2.5, right? This down here has less black than this up here. So that's why it's not C. For A, if I cross up here, it crosses closer, it's over 2.5. So if I go a fifth over, I could see that 2.5 there. You've got to see it, because it's going to get that nitty-gritty on the test. Speaking from getting this test before. And I very rarely use reference points because it's so it's so hard to estimate. But this you can't help. Anything else, it gets even weirder because you got weird numbers. If you take, 1/3 to the -1/5 power, take it times a half plus 2, trying to find the y-intercept gets a little iffy too. So that is what it is. How's your domain typing? I don't know if it'll let you copy it or not. What has happened? I just whacked out of it. Come back here. There we go. I did a control or an option instead of a shift. Okay, less than x, less than positive infinity. And range has to be something with y. Don't forget your y. Again, I'm telling you what I've done wrong in the past. It's above because the 1/2 in front's positive. So now I know what to do with the range. It's a greater than. And I can see the asymptote is 2. Which is K, right? That's where I got it, right there. That's where I get my 2. So check your work if you've already done it. Check it over. Another fun one. Asymptoted 8. It does reflect. So A and B are not it. You guys play that game? Bubblegum in a dish, all that stuff. Yeah. Yeah, that's a silly one. Okay, so it's C or D. Let's see. We both have an 8. Oh, reference point time. So pull out my sticky note. Find my H. That leaves my A plus my K. My reference point's got to be -4 and 6. So if I go 4 to the left and 6 up, that's going to give me the story. So A isn't reflected. Let me see. Oh, 4 to the left. C is out. 4 to the left, 6 up. Beautiful. That's about as imperfectly perfect as you can get with digital software. Domain story does not change. Negative infinity, shift, X, shift, positive infinity, and Y is coming up from the bottom. It will never, let me see, let me look at my graph, see how it never breaks the 8 barrier. So it's always less than 8 because you are adding a negative number to 8. Let me show ya. See this guy? He is always going to be a negative number. He is always going to be a negative number. Always, 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 always. Adding a negative to 8 means it can't go. 8 can't go there. Oh, did I forget something? Little booger, didn't take. Jump to the gun. There we go. All about the proofread. Are you guys ready for the theory? Number theory. Spoiler, none of these match. Why not? The domain, this is the one we're working on this lesson. This guy is from radical. This is a radical. This is a 4th root. This is module 11. So blast from the past. You got to get, this is like calculus. Guys, you got to get the big picture. No matter what I put in for X, I can get something out. That story has not changed. We can't capture infinity. There we go. But whatever I put in a even radical has to start at 0. And now we can use our touchpad for inequality sign and more. I can't put a negative number in an even radical. My calculator will tell me it's a domain error because it's not real. Range. Okay, if I take this guy to a power, he's always going to be, is the K out? Yeah, the range is the K guy, right? So it's plus 0. So Y is greater than 0. Remember, this can never be 0. And it can never be negative because there's no negative A. And 0 is being added out here. All those reasons is a reason why the range is after 0. Here, if I take the 4th root of a number 0 or more, I get out a number 0. That's where the equal comes in, or more. So there's just that little dash under the inequality sign is the only difference on the range. Okay, now we're taking our red curve I have up there on the graph there and watching it zoom. My Y's are getting little, but they will never reach 0. Okay, that's going, as we're reading a book, going to the right, I approach 0. Okay, if I put in a bigger number in here, I get a bigger root out. Like the fourth root of 15 is a value, but then a fourth root of 100 is bigger than a fourth root of 15. So it does grow. The y's grow on a fourth root. They slow down, but they grow. This little graph here looks like this. It still grows, but the bigger the number, it takes longer to grow. But it doesn't have a boundary like an asymptote. It's still, if I take the fourth root of 20 million, it is more than the fourth root of 19,999,999.9099. Okay? Okay, if I go backwards, if this guy is negative, it flips this, doesn't it? So I'm really growing when I go negative. You see the decay? When I get this way, going to infinity. And the graph helps a lot. But it's not easy, guys. It's not easy. But this is my ultimate, this is the mountaintop of this course. It's being able to understand the behaviors of graphs in general without numbers. But it helps to test numbers out. Okay, what happens when x is negative on a radical function that's even? Your calculator says no. And it's because it's not true. You can't, there's no real number for a negative radical, negative under the radical. We did it. Take a picture. It is in the book too. And you might have gotten it already done and you don't understand a licking thing. So all I can ask you is to go back and think about this. Get your thinking cap on and chew on this a while. Last one. Welcome to Algebra 2 Proofs. You're going to prove that a whole number to a negative exponent is just like taking a fraction to a positive exponent. So we got to think of the property that lets me undo a multiplication. And that's the power of a power. So just because a negative x can equal a negative 1 times x and back and forth. If I multiply negative 1 times x, I get a negative x. So that's that proof. What tells me I can change 7 to the negative 1 to 1/7? That's a definition of a negative exponent. So since the last result is exponential decay, the beginning result is an exponential decay. So if you are lurking around pre-calculus, calculus 1, calculus 2, calculus 3, and they ask you, is this an exponential decay function? And you can say, yes, because of the negative exponent with a whole number. End of story. Everybody should have it ready to turn in.